In this video, I thought I would walk through what I mean when I say show your work. And we're going to do a couple of the problems, the exact problems that are on the Chapter 1 assessment, just so that you can understand what I'm looking for when I grade your assessments. Now the first problem here, this is I believe 12A. These are the conversions and one density problem to walk through. But the main thing here is that I know that you learned how to do milligrams to grams probably in middle school, maybe even in elementary school you talked about milligrams and grams. But in chemistry, we need to have a formal procedure in our mind on how to do these problems, because our problems are going to get much more complicated and they're not going to lend themselves to doing them in your head, and they're not going to lend themselves towards sort of remembering a trick and not actually the correct mathematical or science procedure. So when we do a conversion, and I taught this in the video lesson as well, we have a unit, right, a prefix here of milli. So the prefix is milli, and we know milli equals 10 to the minus 3. And then what happens is we can put any unit in front of that. We can say 1 milligram equals 10 to the minus 3 grams. 1 millimeter equals 10 to the minus 3 meters. But it's all based on the fact that milli is defined as 10 to the minus 3. And then from there we can write two different conversion factors or equivalent ratios. 1 milligram over 10 to the minus 3 grams. Or we can write it upside down, 10 to the minus 3 grams over 1 milligram. Both of these conversion factors equal 1. So when I do a conversion, I'm not changing the amount, I'm just changing what unit the amount is shown in. And so for example, on this one, we're taking 15 milligrams, and we want milli to go away, and we want to end up with grams. And so I need to have the milli part of my conversion in the denominator. So I want to use this conversion ratio, because then I can put 1 milligram in the denominator, 10 to the minus 3 grams in the numerator, and then I'm going to show milligrams cancels, and that guarantees that my unit left is grams, which is what I wanted. And so then when I do that multiplication, I get 15 times 10 to the minus 3 grams. But we know that that's not in the correct scientific notation. You should only have one number before the decimal point, so that would be 1.5 times 10 to the minus 2 grams. Okay? Now, if there is another way, and I mentioned this in the video, that if I take that 15 milligrams and I say milli is defined as 10 to the minus 3, I can just replace milli with 10 to the minus 3. So I can say 15 milligrams is the same as 15 times 10 to the minus 3 grams, because this is what milli means. And so I get the same answer, 15 times 10 to the minus 3, which we know is 1.5 times 10 to the minus 2 grams. Now, if you're having a hard time going back and forth from 15 times 10 to the minus 3 to 1.5 times 10 to the minus 2, give me an email, shoot me an email, and I can do another little lesson on that process. I'm assuming that maybe you know that from math, but if not, I can do a little lesson on that. Okay, in our next problem, we have 25,000 nanograms, and we want to get to milligrams. So we have two units here. We have nano equals 10 to the minus 9, and we have milli equals 10 to the minus 3. So then we know nanograms equals 10 to the minus 9 grams, and milligrams equals 10 to the minus 3 grams. I don't want you to go from nano to milli directly, because you're not always going to be able to do that if there's a multi-step conversion problem, especially in the English units. Now, if you're very comfortable doing it and you did nano right to milli and you showed your work, it's fine. That's enough work. But I'm going to do it the way that I've taught you with the prefixes. So we take 25,000 nanograms, and we're going to get rid of the nano, get to grams. So we're going to put 1 nanogram is equal to 10 to the minus 9 grams from this. That's going to show us that nano cancels nanogram. Okay? And then we want milligrams. We want to end up with milligrams. So we're going to put 1 milligram, right? Because this 1 milligram is equal to 10 to the minus 3 grams. And then that's going to show that grams cancels, and the only unit left is milligrams, which is what we want. Now, you can get your calculator out and you can do this, but I'm going to do this without a calculator. I'm going to say this is 2.5 times 10 to the 4. Now, nanograms is canceled, times 10 to the minus 9 times 1 divided by 1 times 10 to the minus 3. Right? So the ones, we don't need to worry about the ones because anything multiplied or divided by 1 is just 1. And so we have 2.5 times, and we have an exponent of 4 plus negative 9, and then divided by negative 3, so minus a minus 3, and that becomes negative 5 plus 3 is negative 2. So the exponent on the 10 is times 10 to the negative 2, and the unit is milligrams. So this is 2.5 times 10 to the negative 2 milligrams. Okay, and then the last question is an actual calculation. It's a density calculation that involves a conversion as part of the calculation. And so if we take a look at this problem, we have gasoline has a density of 0.692 grams per milliliter. So I always tell you, you need to write down what's given in the problem before you start solving. We have a mass. That's what we're trying to find. What is the mass? And then we have a volume of 3.8 gallons. And I'm looking for mass, so the formula on density is density equals mass over volume. So mass is equal to density times volume, right? If I multiply both sides of this equation by V, I get mass equals density times volume. Oops, sorry about that. Okay, so the next step here is we're going to plug in. Now, when we plug in to solve for the mass, we have the density is 0.692 grams per milliliter. And then I need to multiply that by the volume, right? Density times volume. That's going to give me the mass. But if I plug in gallons here, gallons is not going to cancel out milliliters. Now, as we go forward in this year, I'm going to suggest that we do our conversions right in line. So I'm going to show you what that means to do this right in line. If we were to put gallons in here, I'm not going to get a unit for mass. Gallons is not going to cancel milliliters. So what I want to do is I want to also convert from gallons to milliliters. And I know that there are 3,785, I looked this up, and you can do it from the conversions that were in your textbook as well. But there's 3,785 milliliters is equal to 1 gallon. So 3,785 milliliters equals 1 gallon. Now I know I need gallons to go away, so I put the gallon part of this in the denominator, and that cancels that unit. So this step right there, a lot of you probably did this as a separate step, and you could have said over here 3.8 gallons times 3,785 milliliters is equal to 1 gallon. And you could have come up with the fact that that's equal to 14,383 milliliters, right? Gallons is going to cancel. 14,383 milliliters. And you could have said, instead of putting the conversion in the equation here, you could have said mass is equal to 0.692 grams per milliliter, the density, right, times the volume, 14,383 milliliters. So you could have done the conversion outside of the equation, but you don't have to do it outside of the equation, because by putting the conversion right in the equation, it essentially is plugging in the correct number from that conversion. So you can do a conversion right in your equation. And so now when I do this, 0.692 grams per milliliter times 14,383 milliliters, milliliters cancels, and I get 9,953 grams. And I always need to go back and check my sig figs, right? Because here I have 4 sig figs, but in my problem I only had 2 sig figs in my volume, so I have to round that to 2 sig figs. Well, 2 sig figs, this 5 is going to round the 9 up. That's going to become a 10, so that's going to round this 9 up. So this ends up being 10,000 grams. But if I write it like that, These two are my significand, 2 sig figs. That only has 1 sig fig, so I have to write this as 1.0 times 10 to the 4th grams. And so that would be the correct answer for number 13. Okay, so I hope that helps as you're walking through the rest of these problems as to what I am expecting for you to show for work.